In Chapter 10, we're going to take everything we learned in Chapter 9 about atoms, their electrons, valence electrons, and so forth, and then we're going to use that to explain how chemical bonding takes place. So we're going to go from atoms by themselves in Chapter 9 to molecules in Chapter 10. The key observation is that noble gases are unreactive. In other words, they're stable by themselves. They don't need to react with other elements to become more stable. So they do not usually make compounds. But all the other elements on the table are extremely reactive. So to understand bonding, we're going to think of it in terms of reaching the stability of a noble gas in order to lower the energy. In other words, become more stable. The only way that elements can do this to reach that stability is by reacting with other elements. So the rule we're going to apply is called the octet rule. And octet stands for 8, but it's much better to think of this not as 8, but instead group 18. The last digit of 18 obviously is 8, so if you think about trying to reach group 18 stability, that'll make more sense than trying to just reach 8. So we're going to keep track of all of the electrons that we have. And when we do this, we call it a Lewis picture, or a Lewis structure. And there's certain rules for drawing these Lewis structures. The first rule is you draw just the valence electrons, not the core electrons, not the total electrons, but just the valence electrons around the symbol from the periodic table. And when you do that, you can only put a maximum of 2 electrons on each of the 4 sides. So for example, if we took the element lithium, you look on the periodic table, lithium is found in group 1, which means it has 1 valence electron. So we can put 1 dot either top, bottom, left, or right, doesn't matter where we put it, and that 1 dot would represent the 1 valence electron of lithium. If we were drawing the Lewis picture of phosphorus, we would find phosphorus is in group number 15. The last digit is 5, so there are 5 valence electrons. If we put 1, 2, 3, 4, 1 on each of the 4 sides, one of the sides has to have the max of 2 electrons on it. And if we look at a noble gas like argon, found in group 18, it has 8 valence electrons, so we have no choice. Those 8 dots are going to go 2 on the top, 2 on the bottom, 2 on the left, and 2 on the right.